Here is the thing nobody explains about why herbicides stop working. It is not that the weed builds up a tolerance the way a person builds up a tolerance to caffeine. The weed rewrites its own genome, and it does it fast enough that one surviving plant, one plant out of thousands that a herbicide has killed, can fill an entire field with its offspring in 3 growing seasons. And in February of 2008, researchers at North Dakota State University planted roughly 20,000 glyphosate-resistant Palmer amaranth seeds in a 1 square meter circle. That seeding represented the output of a single surviving female plant. By fall of that year, the weed had dispersed 400 feet downslope in rainwater runoff. By 2010, Palmer amaranth covered more than 95% of the total field area. The crop could not be harvested. Complete loss documented start to finish. The weed at the center of this story is Palmer amaranth, Amaranthus palmeri, and it holds the title of the most troublesome weed in U.S. agronomic crop production, according to the Weed Science Society of America. It grows 2 to 3 inches per day in optimal conditions. It reaches 6 to 10 feet tall. A single female plant produces up to 600,000 seeds in a single season. And it has defeated every major class of herbicide American farmers have thrown at it since the late 1980s. The mechanism behind glyphosate resistance, the most consequential resistance case, because glyphosate is the most widely used herbicide in the world, is not a mutation in the classic sense. It is a gene amplification. Glyphosate works by disabling an enzyme called EPSPS, which plants need to produce certain amino acids. Shut down that enzyme and the plant dies. But Palmer amaranth populations across at least 25 states have evolved a workaround. They produce between 5 and 160 extra copies of that gene that encodes that enzyme. With that much EPSPS, protein flooding every cell, glyphosate inhibits some of it, and the rest keeps working. The plant survives the spray. What makes this genuinely strange is where those extra gene copies live. In 2018, researchers confirmed that the amplified EPSPS copies don't sit on the plant's chromosomes in any normal way. They exist on a free-floating, self-replicating ring of DNA inside the cell. 399,000 base pairs of it. That behaves more like a plasmid than a gene. The plant copies it alongside its regular genome every time it divides, passing the resistance mechanism to every offspring. And critically, there is no fitness cost. Resistance plants can grow just as fast, produce just as many seeds, and compete just as aggressively as susceptible ones. Resistance does not weaken them in any detectable way. The first confirmed case of glyphosate resistance Palmer amaranth in the United States was a 250-hectare field in Mason County, Georgia, in 2005. A cotton grower had sprayed the field the previous season and watched plants survive at rates that should have been impossible. Researchers confirmed resistance within 6 years. Every cotton-producing county in Georgia had confirmed infestations. Herbicide input costs in those fields more than doubled. Paraquat applications, largely abandoned for years, came back. Glufosinate came back. Hand weeding crews returned to fields that hadn't needed them in a generation. At an average cost of $57 per hand weeded hectare, a 475% increase over pre-resistant weed management. All of that because one population in one county evolved a mechanism that a single chemistry system had no answer for. Now consider a soybean farmer renting 900 acres in central Illinois. Cash rent running around $230 per acre, margins already thin. Palmer amaranth arrives in the field via contaminated equipment from a neighboring operation or via migratory birds, or in a cover crop seed mixed from a supplier who didn't screen for it. Before that weed establishes, a standard weed control program on soybeans runs roughly $21 per acre. Once Palmer amaranth is confirmed resistant in that field, that cost triples to around $65 per acre for the chemistry alone. And that assumes the chemistry still works. At a density of 8 plants per meter of row, soybean yield loss reaches 78%. Not a bad year. Not drought, not a price collapse, just weeds, left uncontrolled for one season too long. Here is the piece that even people who track herbicide resistance often miss. The class of herbicides farmers turned to after glyphosate failed, PPO inhibitors, applied to soil before weeds emerge, was building resistance the entire time farmers were relying on glyphosate. Because PPOs were applied pre-emergence to the soil surface, there was no visible post-spray failure to signal a problem. The selection pressure accumulated silently for years. When farmers finally went back to PPOs as the fallback, significant populations had already evolved resistance without anyone knowing. The backup weapon had been quietly neutralized while they were using something else. Palmer amaranth has now evolved confirmed resistance to at least 6 distinct herbicide modes of action in the United States: ALS inhibitors, triazines, PS2 inhibitors, dinitrolines, glyphosate, and HPPD inhibitors. Some populations carry resistance to 4 more simultaneously, and because Palmer amaranth is dioecious, male and female flowers growing on separate plants, requiring cross-pollination, wind carries pollen from resistant males to susceptible females across distances up to 1,000 feet. Resistance genes move across fields with every gust of wind, and every seed that plant drops stays viable in the soil for up to 4 years. The last genuinely new herbicide mode of action for post-emergent broadacre weed control was introduced more than 30 years ago. In July of 2025, Bayer submitted registration applications in the US, Brazil, Canada, and the EU for a compound called icafolin methyl, the first new post-emergent broadacre mode of action in over 3 decades. Initial commercial launch is targeted for Brazil in 2028. The US is not next in line. It follows. Between now and then, farmers are managing a weed that defeats every available tool by stacking those same tools at higher rates and higher costs. Soybean herbicide used nationally rose from 1.48 kilograms per hectare in 2005 to 2.74 kilograms per hectare in 2023, an 85% increase in the chemical load per acre. Not because farmers are being reckless, but because resistance has forced them to layer multiple modes of action to accomplish what one used to do alone. The system is not broken. It is working exactly as evolutionary pressure predicts it should. The weed is doing what life does under selective pressure. It's adapting. The question the food system has not fully answered is what happens when the chemistry runs out before the replacement arrives.